After studying this module, you shall be able to analyze frequency distributions and percentiles in SPSS, understand analysis of measures of central tendency through SPSS, convert raw scores to Z-scores by using SPSS, learn to calculate correlation as well as subgroup correlation using SPSS, and know how to calculate linear regression using SPSS. Introduction. The statistical package for the social sciences, or SPSS as it is most commonly used, is a statistical software for managing data and calculating a variety of statistics. In the previous module, we have already learned the basics of SPSS that include opening and exiting the SPSS package, understanding the layout of SPSS, and entering data in the data editor. To analyze a given data in SPSS, it is always important to understand the type of data one is using and what descriptive statistics will be most useful given the type. For continuous or measurement data, one typically report measures of central tendency and measures of variability along with Pearson coefficient of correlation and linear regression. In this module, we will learn to generate reports, analyze the data using descriptive statistics like calculating frequencies and measures of central tendency and variability, along with inferential statistics like correlations and regression. The graphical user interface has two views which can be toggled by clicking on one of the two tabs in the bottom left of the SPSS statistics window. The data view shows a spreadsheet view of the cases, rows and variables in columns. Unlike spreadsheets, the data cells can only contain numbers or text, and formulas cannot be stored in these cells. The variable view displays the metadata dictionary where each row represents a variable and shows the variable name, variable level, value label, print width, measurement type, and a variety of other characteristics. Cells in both views can be manually edited, defining the file structure and allowing data entry without using command syntax. This may be sufficient for small data sets. Larger data sets, such as statistical surveys, are more often created in data entry software or entered during computer-assisted personal interviewing by scanning and using optical character recognition and optical mark recognition software, or by direct capture from online questionnaires. These datasets are then read into SPSS. The developers of the statistical package for the social sciences made every effort to make the software use easy. This prevents an user from making mistakes or even forgetting something. That is not to say it is impossible to do something wrong, but the SPS software works hard to keep the user from running into the ditch. To foul things up, the user almost has to work at figuring out a way of doing something wrong. The user always begins by defining a set of variables, and then he enters data for the variables to create a number of cases. For example, if the user is doing an analysis of automobiles, each car in his study would be a case. The variables that define the cases could be things such as the year of manufacture, horsepower, and cubic inches of displacement. Each car in the study is defined as a single case, and each case is defined as a set of values assigned to the collection of variables. Every case has a value for each variable. Variables also are classified into types. Each variable is defined as containing a specific kind of number. For example, a scale variable is a numeric measurement such as weight or miles per gallon. A categorical variable contains values that define a category. For example, a variable named gender could be a categorical variable defined to contain only values 1 for female and 2 for male. Things that make sense for one type of variable don't necessarily make sense for another. For example, it makes sense to calculate the average miles per gallon but not the average gender. After the user data is entered into SPSS, the cases are all defined by values stored in the variables. The user can run an analysis. The user has already finished the hard part. Running an analysis on the data is much easier than entering the data. To run an analysis, the user selects the one he wants to run from the menu, selects appropriate variables and clicks the OK button. SPSS reads through all the cases, performs the analysis and presents the user with the output. The user can instruct SPSS to draw graphs and charts the same way he instructs it to do an analysis. The user selects the desired graph from the menu, assigns variables to it and clicks OK. When preparing SPSS to run an analysis or draw a graph, the OK button is unavailable until the user has made all the choices necessary to produce output. Not only does SPSS require that the user select a sufficient number of variables to produce output, it also requires that the user choose the right kind of variables. If a categorical variable is required for a certain slot, SPSS will not allow the user to choose any other kind. Whether the output makes sense is up to the user and the data, but SPSS makes certain that the choices the user makes can be used to produce some kind of result. All output from SPSS goes to the same place, a dialog box named SPSS Viewer. It opens to display the results of whatever the user has done. After the user has an output, if he performs some action that produces more output, the new output is displayed in the same dialog box. And almost anything the user does produces output. Frequency distributions and percentiles. The SPSS package can create frequency tables and graphs as well as calculate percentiles. To create a frequency table and to calculate percentile, firstly enter the data in the data editor window by defining the variables in the variable view and then entering the data in the data view. After entering the data, click Analyze on the menu bar, move the cursor to Descriptive Statistics and click on Frequencies as given in the figure. Frequency distributions. A frequency statistic box as in the figure will open. To move the chosen variable under the Variable tab, either highlight the variable and click on the right arrow button or drag and drop the highlighted variable into the space Variables. To remove a variable back from the Variable tab, highlight the variable under the Variable tab and click on the Highlight the variable and click on the left arrow. To create a bar chart or histogram for the frequencies data, click Charts in the Frequencies box. A Frequencies Charts box will appear as shown in the figure. Click on Bar Charts or Histograms in the Frequencies Charts box. Click on Continue and OK and your chart will be displayed in the output. To get the output, click OK and a screen as in the figure will appear. The original scores are arranged in increasing order and are listed towards the left-hand side of the table. The next column indicates the frequency of each score. The percent column represents the percentage of each frequency to the total frequency. The percentile of each score is represented under the cumulative percent column. Plotting frequency polygons. On the menu bar, click on Graphs and click Chart Builder. On the Chart Builder box, click OK and under the Choose From, choose Histogram. Drag the frequency polygon icon into the chart preview area. Drag the variable from the variables column to the area under x-axis. The polygon does not show zero frequency in the absence of a score. The line connects the frequencies of the scores above and below it. Percentile. To determine the score at a particular percentile after entering the data, follow the same procedure as for frequency. Add the required variables under the variable column, click on the Statistics tab, and a Frequency Statistics box will open as shown in the figure. To seek the percentile, place a check mark at percentiles by clicking, type the percentile required, click Add, and the required percentile appears in the white box. Repeat the process to add more percentiles. Click quartiles for the 25th, 50th and the 75th percentile. Use cut points for the 10th, 20th and nth percentile and click Continue. To remove a percentile from the white box, click on the percentile and then click Remove. To get the output, go back to the Frequencies box and click OK. The percentiles will be listed in the output window as given in the figure. Measures of central tendency, variability, and z-scores. This section aims at helping the user to compute measures of central tendency, variability for a sample, and converting raw scores into z-scores. Measures of central tendency and variability. To simultaneously compute the mean, median and mode as well as standard deviation, variance and range for a sample of scores, enter the data and name the variables in the data editor window. Follow the same procedure for the frequency table as discussed in the previous section. When the frequency statistics box appears, choose central tendency and click on the measures that the user is interested in finding out, as given in the figure. The Dispersion tab aims at calculating the variability of the sample scores ranging from the minimum to the maximum. To view the output, click Continue and OK, and the output screen as given in the figure will appear. Z-scores. Enter the raw data in the data editor window. To transform this raw data into z-scores, click on Analyze on the menu bar. Choose Descriptive under the Descriptive Statistics tab and move each variable to the variable in the descriptive box. To select z-scores, checkmark Save Standardized Values as variables, and a figure will appear. To generate the output, click OK. The output will include the mean and the standard deviation of the raw score as given in the figure. The z-score for each raw score will appear in the data editor window as a new variable in a new column as shown in the figure. Correlation and linear regression. This section focuses on analyzing the data by using correlation and linear regression. This is the first inferential statistic that will be illustrated. All the inferential statistics commands in SPSS are given through the Analyze tab on the menu bar. Correlations. Once the user has entered the data in the data editor window, select Correlate, Bivariate under the Analyze tab to calculate the correlation. Bivariate means we are examining the simple association between two variables. In the dialog box as shown in the figure, select the two variables. Select Pearson for correlation coefficients since the data are continuous. The default for test of significance is two-tailed, One could change it to one-tailed if it is a directional hypothesis. Then click the options and select means and standard deviations under statistics as in figure. Missing values are important. In large data sets, pieces of data are often missing for some variables. Click Continue, and when you return to the previous dialog box, click OK, and the output as given in the figure will appear. Subgroup Correlation. SPSS also helps to calculate the correlation between variables separately for subgroups, for example, family type that is nuclear and joint. The easiest way to do this is to split the data file by family type. In the data editor window, select Data Split File as in the figure. The order of the data file will be changed and would be sorted by family type with nuclear family at the top of the file. Select Analyze, Correlation, Bivariate. Select the same variables and options as last time and click OK. The output will be broken down by nuclear and joint family type as displayed in the figure. Linear regression. Regression allows the user to predict variables based on another variable. In this section, we will focus on linear regression or relationships that are linear rather than curvilinear in nature. Illustration: open the file and select Analyze, Regression, Linear. Select one variable as the dependent variable and the other as the independent variable. Then click on Statistics to explore your options. A dialog box as given in the figure will appear. Then select Descriptives and Part and Partial Correlations. SPSS will then calculate the mean and standard deviation for each variable in the equation and the correlation between the two variables. Then click Continue. In the main dialog box, click Save and the dialog box to the left will appear. For predicted values, select Unstandardized and Standardized. For residuals, also select Unstandardized and Standardized. SPSS will save the predicted values of the variable based on the regression equation and the residual or difference between the predicted values and actual values of the variable in the data file. Click Continue. Click Options including a constant in the equation is selected by default. This simply means that both a slope and an intercept, the constant, will appear in the output. Summary. Statistical Package for Social Sciences is a statistical software for managing and analyzing data. SPSS is a widely used program for statistical analysis in social sciences. It is also used by market researchers, health researchers, survey companies, government, education researchers, marketing organizations, data miners, and others. The original SPSS manual has been described as one of sociology's most influential books for allowing ordinary researchers to do their own statistical analysis. In addition to statistical analysis, data management like case selection, file reshaping, creating derived data, and data documentation, a metadata dictionary was stored in the data file are features of the base software. Statistics included in the base software: descriptive statistics, cross-tabulation, frequencies, descriptives, which include mean, standard deviation, explore, descriptive ratio statistics, bivariate statistic, means, t-test, ANOVA, correlation could be bivariate, partial, or distances, and non-parametric tests. Prediction for numerical outcomes, linear regression, and predictions for identifying groups like factor analysis, cluster analysis, which may be two-step, k-means, hierarchical, and discriminant. Descriptive statistics can be used to summarize the data. If the data is categorical, the user can try the frequencies or cross-tabs procedures. Frequencies provide information about the relative frequency of the occurrence of each category of a variable. If the data is scale level, the user can try summaries or descriptives. Descriptives are used to calculate statistics that summarize the values of a variable, like the measures of central tendency, measures of dispersion, skewness, kurtosis, etc. The Correlate submenu provides measures of association for two or more variables measured at the interval level. Bivariate calculates matrices of Pearson product moment correlations with significant levels. The Regression submenu provides a variety of regression techniques, including linear regression, which is used to examine the relationship between a dependent variable and an asset of independent variables.